We've just taken apart the smoke detector.
Is that real americium in there?
Yes, it is. Americium-241.
You think I should touch it?
No, don't touch it. It's radioactive. It might be
What could
fissile.
go wrong? So, Adam, are there different types of radiation?
Yes, there are. There are 4 types we're going to talk about today. Alpha, beta plus, beta minus, and gamma.
In this graph, you can see how atoms will lose neutrons, protons, or both in order to become stable isotopes. In alpha decay, a nucleus with more than 83 protons sheds 2 protons and 2 neutrons to make a smaller atom. Gamma rays are always emitted as the nucleus is restructured.
Man, there are too many people here.
You may have seen this before, but just for review, this is nuclear notation. The element symbol is large and on the right. At the top is the mass number, which is the number of protons and neutrons. Below is the charge number. For nuclei, this is just the number of protons, but for an electron, it is -1. What happens when uranium-238 undergoes alpha decay? It turns into thorium-234. How does plutonium-238 decay to uranium-234? Undergoes alpha decay. Notice the atomic number goes down by 2 and the atomic mass goes down by 4. When an isotope has too many neutrons, beta minus decay occurs. A neutron turns into a proton and an electron. Gamma rays are emitted as usual.
Oh my, there are too many men here.
What happens when cesium-137 undergoes beta decay? Turns into barium-137. What happens when carbon-14 undergoes beta decay? Turns into nitrogen-14. Notice the atomic mass stays the same, but the atomic number goes up by 1. When an isotope has too many protons, it undergoes beta plus decay. A proton turns into a neutron and a positron, which is an antimatter electron. The positron and the electron cancel each other out.
There are too many women here.
How does carbon-11 undergo positron emission? Turns into boron-11. How does potassium-40 undergo positron emission? Turns into argon-40. Notice the atomic number goes down by 1, but the mass number stays the same. It is impossible to predict when an atom will decay, but each atom has a certain chance of decaying, so we can find out when about half will. This is called half-life. In this decay curve for tritium, we see that the amount of tritium halves every 12 years. So the half-life of tritium is 12 years.